Hello students, today we are going to discuss simple machines. Machines are devices which help us to do our work easier and they provide mechanical advantage. In level 2, we discussed about the functions of machines. A machine increases the speed at the expense of force and it increases the force at the expense of speed, and also it changes the direction of force without altering the force or the speed. In this unit, we are going to discuss the simple machines, which our topic for level 3 is inclined planes and screws, and later on we are going to see the mechanical advantage of inclined planes and screws. Inclined planes are used since ancient times. It is believed that Egyptians also used inclined planes to lift heavy objects to build pyramids. What is an inclined plane? An inclined plane is simply a simple machine with no moving parts. It is a sloping surface which helps us to lift heavy objects from a lower surface to a higher surface or from a higher to a lower than lifting an object vertically upwards. Let's look at this figure where a heavy object is lifting upwards using an inclined plane. And if you look at this picture, we can see that the length of the incline is AB, this one. The length of the incline, which is L, and the height is H. So if you look here, we can see that the length of the incline is longer than the height of the incline. That is, L is greater than H. Therefore, it is easy to lift an object from a lower surface to a higher surface because the length is greater than the height. Let's see the mechanical advantage of an inclined plane. Now, in this case, when we talk about mechanical advantage, we need to talk about two forces. The forces are effort force, which is Fe. This is the effort force, which is the force applied on the object, and Fr, which is the resistance force, or sometimes we call it the load force, which is the force which resists or opposes the effort. Resistance force is often called the weight of the object, and weight of the object is calculated using the formula W is equal to mg. Mechanical advantage is the ratio of resistance force over effort force. If the mechanical advantage of the machine is greater than 1, the meaning is that it makes the work more easier. If mechanical advantage is greater than 1, it makes the work more easier. Now in level 2, we discussed about the law of simple machines, which says work input is equal to work output. What is work? Work is the force applied over a distance. So we can simply say work W is equal to force times distance. Therefore, input is the effort force. So work input is Fe multiplied by the distance. We can say Se or De. Let's use Se equal to the work output. Output is the resistance force, so it's Fr multiplied by Sr. Now, we can use this law of simple machine in inclined plane, and we can make this formula as Fe multiplied by the effort distance. Se is the length of the inclined plane, which is L. So, Fe times L equal to Fr times the resistance distance is the height of the incline, which is H. So from here we can rewrite the formula as Fr over Fe equal to L over H. So Fr over Fe is mechanical advantage. Therefore, we can say mechanical advantage of an inclined plane is equal to L over H, which is length of the inclined plane over height. Mechanical advantage of an inclined plane increases as length of the inclined plane increases, and also if height decreases, the mechanical advantage. If height decreases, mechanical advantage increases. Ideal mechanical advantage takes frictionless surface, and actual mechanical advantage consider friction. Now we can do a problem based on inclined plane. The question is as follows. A crate with a weight of 2490 Newton is moved up a ramp that is 3.5 meter long onto a 1.5 meter high platform. Calculate number 1, the ideal mechanical advantage. Number 2, the effort force that is required to move the crate up the slope. Our question says a crate with a weight of 2490 Newton is moved up a ramp. Here is our crate with a weight of 2490 Newton. The weight is already given, so that we don't need to calculate. But if it's not given, then we need to calculate the weight of the object. If mass is given, then we can calculate the weight of the object as W is equal to mg, where the value of g is 9.8 meters per second square. So the weight of the object is given, which is 2490 Newton. It's moved up the ramp, and the length of the ramp or the inclined plane is 3.5 meters long, and the height, the platform is 1.5 meter high. Our first question is to calculate the ideal mechanical advantage. Ideal mechanical advantage of an inclined plane is length of the inclined plane over height of the inclined plane. And in this question, we can see that length is given and height is given. So it's a straightforward question. So we can substitute the values here, which is length is 3.5 over height is 1.5, which gives you 2.33. And now we know that ideal mechanical advantage is the ratio of effort distance over resistance distance. So it's a ratio, therefore we know that there doesn't have any units. Second one, the question says the effort force that is required to move the crate up the slope. So we want to calculate the effort force, and we know that mechanical advantage, simply mechanical advantage is resistance force divided by effort force. Mechanical advantage is resistance force over effort force. So we can replace resistance force by Fg, because resistance force is the load force, and you can see the perpendicular force, which is Fg. So we replace this as Fg over the effort force is the effort is through the incline, and that is the Fa. So we replace it as Fg over Fa. Now our question is the effort force that is required to move the crate up the slope. So we want to calculate Fa. Fa, so we can change the formula as Fa equal to, from here we know the mechanical advantage, so we can say Fa equal to Fg over mechanical advantage. Therefore Fg is already given because the question gives the weight of the object, which is 2490 Newton. If it's not given, we calculate using W is equal to mg if mass is given. So The FG is 2490 over mechanical advantage or ideal mechanical advantage is 2.33, which gives you 1068.67. And what's a unit? It is the effort force. Therefore, the unit is Newton. Next, we are going to discuss mechanical advantage of screws. What is a screw? A screw is an inclined plane wrapped around a cylinder. Screws are part of devices such as car jacks and bench vices. You are all familiar with this screw. We are going to talk about an important term which is called pitch. And pitch is the distance between successive threads on a screw or a jack. Now, if you look at this screw, we can see the spiral part. And this spiral part, we call it the threads. And the distance between successive threads, that is the one which I marked, this and this, the distance between these two threads is called pitch. Once again, these spiral parts are called the threads, and the distance between two successive threads, this distance from here to here or from here to here or from here to here, that distance is called pitch of the screw. Mechanical advantage of a screw, we can use the law of simple machines for the screw also. And the law of simple machine, we know that work input equal to work output, and input is Fe times Se equal to Fr times Sr. Let's use a spanner to understand what is a pitch, and later on we will see the circumference which we are going to use as the effort distance. So if we have a spanner, we want to unscrew something. So our screw is the side, and then here is our effort. We are going to put the force here on the object, and then when we apply the force, when we move, you can see that it's moving in a circular way. When you move this in this manner, we can see that the screw moves from one thread, it moves to the another thread. It means that the distance which the screw, that is here, it travels is a pitch now. Now, when you look at, that is our load distance now. When you talk about the effort distance, that is SE, that is from this point, it travels from here, it travels up to here. We can see it's a circular motion. So from this point, it moves and it comes back to the same point. And we know that is, we can calculate by using the circumference of the circle. This is the center of the circle, and we can see that from here up to here, this is the radius of the circle. So if a question asks using a spanner, then we know that the radius of the circle will be the length of the spanner. Law of simple machine, for effort force multiplied by effort distance equal to resistance force multiplied by resistance force. So it's effort force multiplied by. What is our effort distance? Remember, we said our effort distance will be the circumference of the circle. And circumference of a circle, we know that we calculate using the formula 2 pi r. That is the circumference of the circle because it's moving in a circular motion. 2 pi r equal to Fr multiplied by Sr is the pitch. That is the distance between successive threads. Now we can write the formula as Fr over Fe equal to 2 pi r over pitch. If we cross multiply, Fe times 2 pi r gives Fr times pitch. So our formula is right. Resistance force over effort force, which we call it mechanical advantage. So mechanical advantage of a screw is equal to 2 pi r over pitch. Problem 2 about screw. The question is as follows. A car jack has a pitch of 3.5 millimeter and a handle of 200 millimeters. What is the ideal mechanical advantage? Calculate the load that can be lifted if an effort force of 150 Newton is applied. Determine the actual mechanical advantage if efficiency is 20%. Let's do our first one. The first question says ideal mechanical advantage. It's a car jack, so it's a screw, and the pitch of the car jack is 3.5 millimeters and the length of the handle is 200 millimeters. And we know that ideal mechanical advantage of a screw is 2 pi r over pitch. 2 pi r is the length of the handle, which is 200 millimeters. So it is 2 times 3.14 times. The radius will be the length of the spanner or the car jack, which is 200 millimeters, divided by the pitch is given, which is 3.5 millimeters. Here also this is in millimeters. Now you can see that I didn't convert millimeters into the SI unit, that is the meters, because ideal mechanical advantage is a ratio. So on top it's millimeters and at the bottom also it's millimeters. So they cancel each other. So there is no need to convert, but if you want to, you can convert it to centimeter or you can convert it to the SI unit, that is meter. But if one is given in centimeter and the other one is in millimeter, you must convert them into the same unit. So this is 2 times 3.14 times 200 over 3.5 millimeters. Again, this is a ratio, ideal mechanical advantage, because it's a ratio of effort distance over load distance, so that we know that there won't be any unit because they are ratios. Moving on to the second one, the question says calculate the load that can be lifted if an effort force of 150 Newton is applied. So we want to calculate the load force, or we simply call it the resistance force. And we know that mechanical advantage is Fr over Fe. Fr over Fe. We want to calculate the load, that is the Fr or the resistance. Fr equal to, the formula we can rearrange it as mechanical advantage multiplied by the effort force. And mechanical advantage we already calculate in the first question, which is 358.86 multiplied by the effort force is given in the question, which is 150 Newton, which is equal to 53,829, and this is the force, therefore the unit is Newton. Third question, determine the actual mechanical advantage if the efficiency is 20%. In level 2 we did efficiency, and we know that efficiency of a simple machine is equal to actual mechanical advantage over ideal mechanical advantage times 100, but because to convert it to percentage. So efficiency is actual mechanical advantage over ideal mechanical advantage. Our question is to calculate actual mechanical advantage. Therefore, we change our formula as actual mechanical advantage equal to efficiency multiplied by ideal mechanical advantage. And efficiency is given in the question, it says 20%, and we know percentage means out of 100 multiply by ideal mechanical advantage. We already calculate in our first question, so it is 358.86, which gives us 71.77. Again, ideal mechanical advantage is a ratio, therefore doesn't have any units. Problem 3, which is NCV supplementary 2016 paper 1. The question is as follows. A crate with a mass of 50 kg is to be raised to a high level by using a frictionless inclined plane that slopes at an angle of 20 degrees to the horizontal. Calculate the magnitude of the minimum force required to carry this out at a constant speed, and also calculate the mechanical advantage. This is the question. Is an inclined plane where an object is raised to a higher level, and what is given is the angle of inclination, the theta, which is 20 degrees. When you look at this question, you can see that length or height is not given. Instead of that, what is given is the theta, which is 20 degrees. So the question is to calculate the effort force. What will we do if we want to calculate the ideal mechanical advantage using the theta value? Now, if you look at this, you know that it's a right angular triangle, and this is the opposite side of, because this is our theta, and this is the opposite side, and this is the hypotenuse. So we can use the trigonometric identity, that is sine theta equal to opposite side, which is h over hypotenuse is L. So it's h over L. And we know that ideal mechanical advantage of an inclined plane is length of the incline over height of the incline. So in this case, we can see that it is L over H, but from the trigonometric identity, we got H over L. But we can make it L over H so that we can use it in our formula. So what we do is we take the reciprocal of this. So when you do something on the left hand side, you must do it on the right hand side. So when you take the reciprocal, this becomes L over H. So this is 1 over H over L will give you 1 over sine theta. Therefore, we change this as L over H equal to 1 over sine theta. So we take the reciprocal, 1 over H over L equal to, the reciprocal is 1 over sine theta. So this one is inverse. So it's L over H equal to 1 over sine theta. So we have L over H as 1 over sine theta. So we are going to replace our formula, that is ideal mechanical advantage is equal to, instead of L over H, we are going to say it's 1 over sine theta. So if we have theta given, this is how we are going to calculate ideal mechanical advantage, which is 1 over sine theta. So in this question, we can calculate ideal mechanical advantage equal to 1 divided by sine theta is 20 degree, which gives you 2.92. Again, it's a ratio, therefore doesn't have any unit. So my ideal mechanical advantage is 2.92, or simply mechanical advantage. Our question is to calculate the minimum effort, so the effort force. So we still need to continue. So mechanical advantage is equal to the resistance force divided by effort force. And we want to calculate effort force. So our formula, which changes into Fe equal to Fr over mechanical advantage, and Fr is, it's not given, but the mass of the object is given. The question says mass of the object is 50 kg, and we know how to calculate this because in the beginning we said the resistance force is often called as the weight of the object, and we know that to calculate the weight we use the formula W is equal to mg. So it is 50 multiplied by 9.8 over mechanical advantage is 2.92. So it's 2.92, which gives the value 167.81 Newton, because it's a force. Effort force is 167.81 Newton. Second one, The question is calculate the ideal mechanical advantage. So simply we know that mechanical advantage or ideal mechanical advantage we already calculate here. So it is 2.92. Problem 4, which is NCV number 29, paper 1. The question is as follows. A tire of a sports car with a mass of 2500 kg has to be changed. The vehicle is raised by a jack that has a pitch of 0.4 cm and a 25 cm handle. First question, what is the ideal mechanical advantage of the jack? Second one, calculate the resistance that can be lifted if an effort force of 150 Newton is applied. Third one, calculate the actual mechanical advantage if the efficiency is 20%. Calculate the actual effort that is needed to lift the vehicle. Let's look at our first question, which need to calculate the ideal mechanical advantage. Ideal mechanical advantage, it's about a screw noun. Ideal mechanical advantage equal to 2 pi r over pitch. In some of the questions, they can also ask velocity ratio. Ideal mechanical advantage, it's the same as velocity ratio. So don't get confused. If the question asks velocity ratio, it's still ideal mechanical advantage. 2 pi r over pitch. 2 times 3.14 multiplied by the radius is given, which is 25 centimeters, divided by the pitch is also given, which is 0.4. Therefore, ideal mechanical advantage is equal to 392.5. Second one, the question is to calculate the resistance or the load. So we know that mechanical advantage equal to the load force over the resistance force over the effort force, and we want to calculate the load force, so we change our formulas. Fr equal to mechanical advantage times Fe, which is equal to mechanical advantage is already calculate, which is 392.5 multiplied by the effort is given, which is 150. So the resistance force is 58,875, and this is the force, so that much Newton. Third question, actual mechanical advantage. Efficiency is given, it's 20%. So efficiency equal to actual mechanical advantage over ideal mechanical advantage. And we want to calculate the actual mechanical advantage, which is equal to efficiency multiplied by ideal mechanical advantage, 20 over 100, because it's given it's 20%, times ideal mechanical advantage is 392.5, which gives you 78.5. That is the actual mechanical advantage, and that is also a ratio, so it doesn't have any units. Next, we want to calculate the minimum effort. So actual mechanical advantage is Fr over Fe. From there we can say Fe equal to Fr over actual mechanical advantage. So we substitute the values, that is Fr is the mass of the object is given, which is 2500 times 9.8. We discussed this in the previous question, because if the resistance force, if the mass of the object is given, we can calculate the resistance force by using the formula W is equal to mg. So it's m times g 9.8 over actual mechanical advantage. We calculate in number C, which is 78.5. Therefore, we get effort force Fe, which is equal to 312.1 Newton. Let's look at the summary of today's lesson. We did simple machines, and we know that a machine, which is a device which help us to do our work easier, and we saw the functions of simple machines or simply machines, and we did the mechanical advantage of an inclined plane and a screw, and we know that mechanical advantage of an inclined plane is length of the incline divided by height of the incline. And also we know that if theta is only given, now we know that mechanical advantage is 1 over sine theta. And also we know that if length of the inclined plane increases, mechanical advantage also increases, and if the slope decreases, the mechanical advantage also increases. Then we did the second simple machine, which is screws, and screws are inclined planes which are wrapped around a cylinder, and the mechanical advantage of a screw is 2 pi r over pitch, and this is the effort distance and this is the load distance.